Hi friends, we have discussed about angular momentum and torque of every individual particle. We define it for single particle, but the body is not a single particle. Body is made up of many particles which we call as a system of particles. Therefore, now we are going to extend the concept of angular momentum and torque to a system of particles, that is to a rigid body. So angular momentum to a system of it's an angular momentum to a system of particles. See this one. This is, we call this thing as a generalization. We have taken. So, angular momentum L is nothing but R cross P for single one. Angular momentum of a single particle about a point is vector product of arc and linear momentum. R is called as R. Now, suppose this is the rigid body and it is rotating about one axis and it consists, this is M1, this is M2, this is M3, this is M4, so on Mn. It consists n number of particles, M1, mass of M1, and so on, Mn. It has n number of particles. These particles are at a distance R1, R2, R3 and Rn from origin. It is their position from origin. So we say there are different particles and their positions from origin are R1, R2, R3 and so on Rn. Therefore, individual particle L1 is equal to R1 cross P1. Angular momentum of first particle is R1 cross P1. Similarly, L2 is equal to R2 cross P2. Ln is equal to Rn cross Pn. These are a system of n particles. Total angular momentum is nothing but this is L1 plus L2 plus L3 so on Ln. Total angular momentum is summation of all these angular momentums. Then it becomes, when we are taking L1 is equal to R1 cross P1. It's a 1. Similarly, R2 cross P2 plus so on, Rn cross Pn. L is equal to summation of Li. I goes from 1 to n. This is called as generalization of the concept of angular momentum to a system of n particle body. This one we get it. This one, if you check this one, L is equal to summation Ri cross Pr. I goes from n to n. So it is the sum of all the particles, leading angular momentum of all the particles. Now this became the formula, or this is the angular momentum for a system of particles. Now this generalization we can extend it to the force, or this we can extend it to then the concept of this angular momentum we can torque of a system of particles. System of consider about a point. It is about any point we consider. L, already we considered summation Li, I goes from 1 to n, which is equal to summation I goes from 1 to n, Ri cross Pi. Ri cross Pi. Now, let us differentiate dl by dt. We differentiate this one. When we are differentiating this thing, single one, we get it ddt of summation Ri cross Pi. We have taken differentiation of both the sides. What does it mean? It means that ddt of L1 plus L2 plus L3 so on Ln. This is dl by dt is nothing but summation of this. Now L1 is what? L1 is equal to R1 cross P1. L2 is what? R2 cross P2. Ln is what? L2 is equal to R2 cross P2. Ln is equal to Rn cross Pn. So this side we replace by this one. This dl by dt is equal to ddt of summation, or ddt of, we can write it, not summation. It is R1 cross P1 plus R2 cross P2 plus so on Rn cross Pn. We know this is, when we are taking it, here it becomes torque. This is becoming torque, one side. The torques are, there are two torques. Torque is equal to R cross F. So this is also equal to R cross F external plus F internal. Two are there. Forces are external also and forces are internal also. Now for internal forces, we all know, according to Newton's law, the internal forces, one particle exert force on another one, and in the same pair, second particle exerts equal and opposite force on first. Therefore, they nullify. So action and reaction is equal and opposite. That is one way internal forces vanish. Another thing, internal forces are always along the line joining two particles, and this is along the axis. R becomes 0 here, or this is along the axis. This is also another reason why F internal is 0. So F internal is equal to 0. Torque remains R cross F external. This is for every individual particle. It remains R cross F, or this one is R cross F. So we can check it. These all things. Let us take it this one. dl by dt is equal to, it is d R cross dp by dt 1. Similarly, R2 cross dp 2 by dt plus Rn cross dpn by dt. So this is nothing but force. According to Newton's second law, it is force. Therefore, dl by dt is equal to R1 F1, but it is only external. Internal force became 0. Similarly, R2 cross F2 external plus Rn cross Fn external, we get it dl by dt is equal to summation Ri cross Fi external, it goes from 1 to n. R cross F is equal to torque, that becomes summation to R, I goes from 1 to n. and then we get equation dl by dt is equal to torque 1, torque 2, so on, torque 3. The torque due to external force, internal force we do not. So dl by dt is nothing but torque due to external force on every individual particle, summation. But by definition, this becomes the torque, total torque. Therefore, total torque is equal to summation of individual torque, which is equal to dl by dt. We reach to the Newton's second law in rotational motion. Now see this one. Finally, we reach to the equation. It is one particle system and then many particle system. We generalize it. We have applied it to that one. It became to many particle systems. We have generalized these things. So, torque is equal to summation of tau I. Therefore, torque is equal to dl by dt. You can see torque is, what is the torque? Is time rate of angular momentum of a system of particles. Angular momentum of a system of particles about a point. It is torque is defined as time rate of angular momentum of system of particles about a point. Here we come to a precise definition of torque. The F is equal to dp by dt. Similar way, we get torque is equal to dl by dt. So, single particle system we generalized and we applied it to the many particle system. Now, from this equation, we come to the law of conservation of angular momentum, which is very important. It is what I am saying. It is important law of conservation of angular momentum. See this. What is the meaning of law of conservation of angular momentum? We got it. Torque is equal to dl by dt. If this is equal to 0, if net torque acting due to external force on a system of particle is 0, we get dl by dt is 0. It means that dl is equal to 0. Change in angular momentum is 0. It means that L is constant. It is L is constant, and we come to the conclusion of very important law. For an isolated system, if the torque acting on the system is 0, net torque acting on the system is 0, its angular momentum is constant. This is called as law of conservation of angular momentum. The way law of conservation of linear momentum holds good, the law of conservation of angular momentum also holds good. This is, and it is again a universal law. You all know L is constant, but L, it has a three components. L is equal to Lxr, Lyj plus Lzk. As soon as we say that L is equal to K1, constant. X component of angular momentum is constant if net torque acting on a system of particle about a point is 0. Similarly, Ly is equal to K2, Lz is equal to K3. We get three constants. We get three different equations in this case. So, in this complete topic, we have generalized angular momentum and torque. We derived relation between angular momentum and torque, and then finally we came to conclusion that the angular momentum is conserved if net torque acting on an isolated system about a point is zero. That's all about this topic. Thank you.